Hope Llewellyn here this evening. I'm a four-time Paralympian and an amputee for many years, since 1989. Then I had the great fortune to start working with Levi Hargrove at the Shirley Ryan Ability Lab in research. Thank you, Levi. I'm glad to be here and talking to you. So we've had a lot of changes in this industry, and I know I started on something like this, mechanical leg. Tell us what we have here.
Yeah, so prosthetic technology is centuries, if not millennia old. So some early work shows that people are using prosthetic arms or legs thousands of years ago. It really took a tremendous leap forward after the US Civil War. And so then you started to see some more sophisticated limbs. They were still wooden, still passive. This particular device is kind of an evolution of that technology. So there are no motors on it. It's a fancy walking stick. It's a very capable device.
Yes.
But it's not a smart device. It's not a bionic device. This particular device is a powered leg. So this is a bionic leg. It has motors. It has powered by a large battery, and it's smart. So we have sensors in the socket that would measure your muscle signals.
That's cool.
From these muscle signals, we send them down this wire to a computer, and then we use artificial intelligence to teach the device how to respond to your movements and your thoughts. We do have some great enhancements that we've made since we started this work in 2012, and so we used other people's devices when we started, and then we wanted to move on to build some of our own.
Is that what's over there?
That is absolutely what's over there. Let's
check
go
it
have
out.
a look.
Okay, let's see what we have here. I enjoy this table because, like I said, I was an aircraft mechanic, so I like technology, and I know there's some cool stuff here. What do we have?
Yeah, so as I mentioned previously, we really wanted to design and build some of our own bionic leg technologies. So we assemble these components, we design them into something like this, which you've walked on. Yep. So this is your bionic leg that you've walked on in here many times. So we're smart, we assemble it, and then we put the computer on the front to kind of teach the leg how to respond to your signals.
Yeah.
So what we're doing now is we're taking these components and we've replicated them in a much smaller package.
So I'm not sure I understand. Clear this up, because this would be incredible. This part and this part are equal, meaning, well, you tell me.
Yeah, so the leg we know is a bit too heavy, it's a bit too loud. So what we've been able to do in the past year or so is take all of these components, all the silver, and reduce it in size and weight to
that.
this. So you can imagine walking with something that weighs the equivalent of this, which is heavy to pick up, into these three components.
Nothing, yeah.
So this is a fully bionic knee. It's smart, it's lightweight, it's designed entirely here in-house.
How cool.
Yeah. So we can take this knee and we can attach it to any one of our ankles over here.
Let's go look. What's interesting about this is knees always seem to be the star of the show, but maybe people don't realize how important the ankle is.
Yeah, ankles are very important. So this is actually one of the very first bionic ankle prototypes. But you can see it's kind of tall. It's also heavy, needs a battery. But definitely a step forward in the field of bionics. So this would be a early 2008 ankle prototype.
Okay. Yeah. And this one?
So this is one of the ones that we've designed here. We actually call this the magic ankle.
Okay.
And so this is an ankle that as you walk, it automatically will figure out what angle your toe should hit the ground at. So if you're walking up and down a slope, this will automatically adjust to make it a more comfortable foot strike. And it works pretty well. It has to be very smart.
Yeah. Yeah, I didn't have any complaints. What do we have next?
So these are some of the newer devices that we're just beginning to work on.
Oh, okay.
This device kind of behaves like a dynamic diving board as you walk, but the motor will move very quickly to make this either very stiff to help push you along, or springy or compliant that will make it a nice, comfortable, soft landing as you walk. And so this is a research prototype that we're just kind of starting to work with. This is a fully powered ankle. It's going to push you on every step. Wow. It's kind of in the design phase. And so you can see this is what a lot of our prototypes look like, as you know. There are wires hanging off. We need to design clean, miniaturize,
Right.
and harden. So we'll go through all of the steps with this device and make a shorter, lighter version of the far one that you see there.
And I recognize that sleeve a little bit. I mean, it's not mine, but I've recognized the...
This one actually might be yours. So as you know, one of the goals is to make this device so easy to put on, just like a shoe,
Yes.
right? So you can just slip it on and go.
Yes.
And as of now, there's quite often a team of engineers that we need to work with, and therapists and clinicians to get set up and go. We want to make this just so that you put it on, roll it on, click in and go. Yeah. And so this is kind of a step in that direction to get to a easy to use, everyday bionic limb that's going to be robust and work well for you. And of course, this would just slip into a socket and you'd be good to go.
So after all these big, heavy things, we've kept coming down and down and down, smaller and smaller. And what do we have right here?
Yeah, so this is something we're really excited about. This is actually an implant that we can put inside of your body to measure your neural signals. So it's tiny, it's wirelessly powered, sends data out wirelessly, and once we place them inside of the muscles that are still remaining and healthy in your residual limb, we're going to be able to figure out things like when you want to stand on your tiptoes or how hard you want to push when you walk. So you can imagine taking a technology like this and then coupling it with an emerging technology called osseointegration, where you would no longer even need a socket.
What?
Right? So you kind of clip your leg on and off you go.
Oh, man.
And that's where we're trying to get with the work that we're doing here. We just think that would be an interesting and very impactful technology to provide as an option.
Sounds amazing. I just want to say I'm so excited with what you guys do here, and I'm really privileged to help you with it. And it means so much to all of us what you do here, because we know it's going to make for a better life for all of us. So thank you very much.
Absolutely, and thank you. Your input is invaluable, and we couldn't do it without you.
Sounds like a good team.
Absolutely.